When we think about a disease like ALS, we often imagine scientists in a lab staring down a microscope. But today, we're going to do the opposite. We're going to zoom way out and look at ALS from the population level to really understand what the big picture can tell us about this incredibly complex disease.
Right, so when you're faced with something like ALS, a few basic questions probably pop into your head immediately. Like, how many people have it? Who tends to get it? Is it more common in certain parts of the world? And these aren't just idle questions, They are the absolute starting point for a massive scientific investigation.
And the lead detective in that whole investigation? Well, it has a special name, epidemiology. I know, it sounds a little complicated, but just think of it as the science of playing detective, but for diseases, and on a huge, sometimes global scale. It's how we spot the patterns that can lead to major breakthroughs.
So at its heart, epidemiology is all about seeing the forest for the trees. Instead of looking at one single case, it looks at how diseases move through entire populations. It helps us figure out who's at risk, where it's happening, and, this is the big one, start to uncover the reasons why. It really turns all those individual stories into a giant map that guides the search for answers.
Okay, so let's grab our detective tools and tackle that first big question. Just how common is ALS? And to really do it right, we need to get a handle on two key ideas that tell slightly different parts of the story: incidence and prevalence.
It's actually pretty simple when you break it down. Incidence is all about the new cases diagnosed each year. Think of it like the flow of water into a bathtub. Prevalence, on the other hand, is the total number of people living with the disease at any one time. So that's all the water that's currently in the tub.
So, what's the incidence rate look like? Well, in most Western countries, it's about 1.5 to 2.5 new cases for every single 100,000 people every year. To put that in perspective, in a country the size of the US, that adds up to somewhere between 5,000 and 6,000 new diagnoses annually. And because people live with ALS for years after their diagnosis, that water stays in the tub, right? So the prevalence, the total amount of water, is much, much higher. In the United States alone, we estimate that between 20,000 and 30,000 people are living with ALS right now. All right, now that we have a sense of the scale, the detective story moves on to the next set of clues. Who is most likely to be diagnosed? Where in the world do we see it more often? And when in someone's life does it typically show up?
Let's start with the when. The single biggest predictor for ALS, by far, is age. Now, it can technically strike at any age, but the vast majority of people are diagnosed later in life. We're talking about a window typically between 55 and 75, with the average age of onset right around 63.
Now let's talk about who. This chart shows a really clear pattern with gender. Men are about 20 to 30% more likely to develop ALS than women. But check out that note at the bottom, because this is a fascinating clue. That gender gap pretty much vanishes after age 70. The rates become almost identical.
Okay, now for the where. And this is one of the most famous stories in the history of ALS research. It didn't come from a fancy lab, it came from a tiny island in the Pacific. Back in the mid-20th century, a mysterious ALS-like disease started showing up in Guam at rates that were up to 100 times higher than anywhere else on the planet. This bizarre cluster was a puzzle for decades, but it gave researchers one of their most powerful clues ever. The investigation ultimately pointed to environmental exposures, specifically a neurotoxin from the seeds of local plants that were part of the diet. It was this massive, groundbreaking discovery, and it proved that our environment can play a huge role in the risk for ALS.
And this leads us right to the central mystery that scientists are still trying to crack. What actually causes ALS? Well, the investigation is really zeroed in on two main suspects: the genetic blueprint we're all born with, and all the environmental factors we're exposed to throughout our lives.
Let's just look at the breakdown here. About 90% of all ALS cases are what we call sporadic, which just means they happen out of the blue, with no known family history. But a really critical 5 to 10% of cases are familial. They're directly inherited, and this is our definitive proof that genetics absolutely plays a role.
So what about that other piece of the puzzle, the environment? Well, all this detective work has pointed to several potential risk factors. Studies have found links with things like military service, exposure to pesticides or heavy metals, and even head trauma. Now, it's super important to remember, these are correlations, right? Not a definitive cause, but they give researchers these vital trails to follow.
And this is really where the modern understanding of ALS is right now. It's probably not just about your genes or your environment. No, it's more like a really complex dance between the two. The leading theory is that some people might have a genetic makeup that just makes them a bit more vulnerable to certain environmental triggers that they might run into over their lifetime.
So we've looked at incidence, prevalence, demographics, risk factors, the whole shebang. But what's the point of all this? I mean, how does digging into all these patterns actually help in the real world, in the fight against ALS? Let's connect the dots.
Take a look at these survival statistics. The median survival time is about 3 to 5 years, but this data shows just incredible variability. About 20% of people live more than 5 years, and a full 10% live for more than a decade. Now that variation, that is another huge clue for scientists. If we can just figure out why some people live so much longer, it could unlock brand new strategies for everyone.
And get this, there's actually a really surprising sign of hope hidden in the data. In some places, the total number of people living with ALS is actually going up slowly. And this isn't because more people are getting sick. It's likely a sign of progress. It probably reflects better supportive care, especially things like breathing and nutritional support. It's helping people live longer, fuller lives with the disease.
So you see, this is the practical roadmap that epidemiology gives us. It starts with collecting data. That data helps us find clues and spot trends. Then, armed with that knowledge, scientists can design much smarter clinical trials. And all of that helps guide how we spend money and focus care to make the biggest possible impact. It's a really clear path from data to discovery.
Finally, and I think this is the most important takeaway of all, we have to remember that these are never just numbers on a chart. Behind every single statistic is a real person, a family, a community. Their collective experiences are what create the data that drives science forward, turning individual struggles into a shared mission for a cure.
Which leaves us with one last forward-looking question. Our ability to gather and analyze data is just exploding right now. I mean, we have powerful new tools like large-scale genomics, AI, wearable health tech. The detective work is getting more powerful every single day. So the question we're left with is, what new, game-changing clues are we about to find buried in all that data?